In the last session, we looked at the first part of the scientific history of India. There are several things to discuss, but we took only two of them. One is the decimal number system, the place value system with the zero. And another is Aryabhata, as a mathematician scientist, his contributions around the 5th and 6th centuries. That is, his time was 476 AD to 550 AD. Aryabhata, no doubt, is one of the finest mathematicians the world has seen. If you count the contributions and the brilliance and the impact across the world, Aryabhata certainly stands on the topmost echelon of the ladder. I would rate Aryabhata, Bhaskaracharya and Ramanujam as the three greatest mathematicians of not only India, but certainly the whole world. There are others in the Western hemisphere, among the Western mathematicians, Isaac Newton, Leonard Euler, and Carl Friedrich Gauss. They are rated as the topmost three mathematicians in the Western world. Of course, when the West says it, it is the whole world. Of course, in this whole line, certainly Aryabhata, Bhaskara and Ramanujam should be counted as the top mathematicians in the history of mankind. Today we shall look at Bhaskara and then several other mathematicians, and whatever the rest of the topics which we had listed last time, we will cover today. Bhaskara belonged to Karnataka, a village near Bijapur or Vijayapur today. He lived in between 1114 to 1185, that is the 12th century. He has written two major treatises. One is known as the Siddhanta Shiromani and another is known as Karana Kutuhala. The Siddhanta Shiromani contains 4 books, subsections: Leelavati, Bijaganita, Grahaganita and Goladhyaya. I will begin with a story. This story belongs to Europe in the 17th century. See, by that time, already in Europe, this printing machine had come, and therefore there were newspapers also. And it was a period of Renaissance when a lot of intellectual activity was going on. And the incident I am referring to belongs to France. There was a great mathematician by name Fermat. Fermat's last theorem and all that. Very great mathematician. He was a jurist by profession, but a mathematician by inclination and aptitude. So Fermat was very fond of debates. And since the newspapers were there, it was a pleasure to. So he would indulge in a lot of debates. What he would do is he would publish advertisement in the newspaper, posing a challenge to some of his colleagues. He said, solve if you can. So one such incident is that he posed this question: solve if you can 61x square plus 1 equal to y square. Possibly he referred to one of his friends by name Frenicle D. Bessy. He said, solve if you can. And Bessy tried to solve this. I mean, the condition was this. The equation, if you see, it is an algebraic equation, but a second order equation. And it contains x and y, two terms. And in algebra, we know that if you have to solve an equation with two variables, we need two equations. But he gave only one equation, but then another condition. He said condition. Condition is that x and y both are integers. Solve if you can. And tell me what is x and what is y. D. Bessy could not solve it. The year was 1657, but then D. Bessy died without solving it. And Fermat died without giving the answer. 1665, Fermat was dead. But this problem of Fermat was intriguing to many mathematicians, and it was finally solved by Euler, whose name I mentioned earlier as one of the greatest mathematicians in human history. Euler, a Swiss mathematician, he solved it in 1732. That is 75 years after the problem was posed by Fermat. The answer was this. See, if you look at the equation, you can see easily that 61x square plus 1 equal to y square. So if you neglect that 1, it is 61. And if you make that 61 into 64, it becomes that y is 8 times larger than x. So it should be very, very nearly 8 times larger than x. But the numbers are so huge. Integers which you can solve this equation are so huge. And it is not easy to handle this kind of numbers. You see, the x itself is a 9-digit number and y is a 10-digit number. But Euler solved it, such large number. But what Fermat did not say at the time of posing this problem is that Bhaskara had solved this problem and put it up in his Siddhanta Shiromani something like 500 years earlier. This problem was Bhaskara's Bijaganita, a section of Siddhanta Shiromani, as an illustrated example for the Chakravala method of solving indeterminate equations. The equation is called indeterminate. It is not easy to solve that, not solvable. But Bhaskara had solved it. The interesting thing is, it is not that one problem is solved. Euler had solved one problem. It is not that solving just one problem, but he developed a method called the Chakravala method, that is cyclic iteration method, which can solve this class of problems. Indeterminate equations, how to solve them? You can solve it by Chakravala method. That was developed by Bhaskara. I said it was developed. In fact, it was finalized by Bhaskara. It was discussed much before Bhaskara. Bhaskara is some 600 years earlier to Euler, but there are people who worked on the Chakravala method earlier to Bhaskara. It was started even earlier. I think Aryabhata also refers to it. Brahmagupta also refers to it. That is the greatness of Bhaskara, or Indian mathematicians, you can say. Bhaskara's work on calculus predates Newton and Leibniz by half a millennium, that is 500 years. He is particularly known in the discovery of the principles of differential calculus and its application to astronomical problems and computations. This differential calculus is attributed to Isaac Newton and Leibniz. interruption, sorry.
Yes, sir.
Yeah, can I continue?
Yes, please.
Yeah. Bhaskara's work on calculus predated Newton and Leibniz by half a millennium. Newton and Leibniz both are considered to be the father figures for differential calculus. But Indian mathematicians had referred to this and developed differential calculus much earlier. And the Chakravarna method was known earlier to Jayadeva, that is around 1000 AD, but was perfected by Bhaskara for solving indeterminate equations of the form ax square plus bx plus c equal to y. Now I am quoting Professor Selenius. Selenius is a mathematician, a professor in the Uppsala University of Sweden. Look at the quotation and look at the words he uses. It's a tribute to Bhaskara. He says that the Chakravarna method anticipated the European methods by more than 1,000 years. The cyclic iteration method developed in the Europe was anticipated in India by more than 1,000 years earlier and surpassed all other Oriental performances. In my opinion, no European performance at the time of Bhaskara, nor much later, came up to this marvelous height of mathematical complexity. Look at the words. He's saying the European development, European performance at the time of Bhaskara was nowhere comparable to the Indian mathematical geniuses and knowledge. Marvelous height of mathematical complexity, he says. And he says that this Chakravarna method surpasses all other Oriental performances. Now, this has to be taken with a pinch of salt because Professor Selenius is a mathematician and he looks at mathematics and some achievement in the mathematics and says that this is the greatest achievement of India. In fact, I will show you later various other scientists in various different departments acknowledge the greatness of India in those respective domains. Coming back to Chakravarna method, Hermann Hankel, a German mathematician, says that Chakravarna is the finest thing achieved in the theory of numbers before Lagrange. The gravitational law of Newton was presented in 1687. It is certainly one of the finest scientific achievements. But Bhaskaracharya, in his Siddhanta Shiromani, had written that things fall on the earth because of the force of attraction, and that this force is responsible for keeping the heavenly bodies in the sky. More than 500 years before Newton formulated his gravitational law. He did not give a formula like Newton did, but he identified the force of attraction. This is the quote from Bhaskaracharya's work. The Sanskrit quote is here. It means the attracting force is the earth. The earth attracts large objects in the sky towards herself. It appears as though she would fall, but the space with matching forces, how would she fall? So the mutual attraction, the matching forces that keeps the objects in the sky was observed by Bhaskara. Brahmagupta and Madhavacharya. I had referred to Fibonacci and Fibonacci series in my last presentation. Fibonacci belonged to the period of 1200 AD in Italy. And there is a series known by his name, Fibonacci series. It starts 0, 1, 1, 2, 3, 5, 8, like this it goes. The number, a particular number is the sum of the previous two numbers. That is Fibonacci series algorithm. So 0 and 1 you write, and then say the next one is the sum of these two, which is 1. And the next one will be sum of 1 and 1, which is 2. Then 1 and 2, which is 3. Like that it goes on. But this Fibonacci series is very useful, and all computer engineers, electronic engineers, communication engineers are familiar with this. This sequence was well known in South Asia and used in the metrical sciences. Its development is attributed in part to, in India, to Pingala in 200 BC. Mind you, Fibonacci is 1200 AD, and we are referring to Pingala, who was 1400 years earlier to Fibonacci. Later being associated with Virahanka in 700 AD, Gopala in 1135 AD, and Hemachandra in 1150 AD, all of whom lived and worked prior to Fibonacci. Pell's equation. There is something called a Pell's equation, which is the indeterminate equation which we referred to a little earlier. It is known as any Diophantine equation of the form x square minus ny square equal to 1. The name of this equation arose from Leonhard Euler's mistakenly attributing its study to John Pell. It is called Pell's equation, but Pell was not the originator of this equation. He was not the original founder of this equation or formulator. It was Lord Brouncker. Euler was aware of the work of Lord Brouncker, the first European mathematician to find a general solution of the equation, but apparently confused Brouncker with Pell, hence the name stuck as Pell's equation. But this equation, we have already discussed this, this equation was first studied extensively in ancient India, starting with Brahmagupta in 628 AD, who developed the Chakravarti method to solve what is later known as Pell's equation and other quadratic indeterminate equations in his Brahma Sphuta Siddhanta in 628 AD, about 1,000 years before Pell's time. Brahmagupta had worked on the Chakravarti method, but then Bhaskara refined it and perfected it. But 628 AD, Chakravarti method. Madhavacharya belonged to Kerala in the 15th century, 14th and 15th century. Used Gregory's series 2 centuries before James Gregory. See, the series is known by Gregory, James Gregory's name, a Scottish mathematician belonging to Scotland. But it was known in India and used by Madhavacharya 2 centuries earlier to Gregory. And Madhavacharya used it to calculate the value of pi, which is the ratio of the circumference to the diameter of a circle, of any circle, correct to 10 decimal places. This is the equation which Madhava used in Kerala around 1400 AD. Madhava had worked on the infinite series around 1400 AD, predated Newton, who worked on infinite series in 1670, and Leibniz in 1676. They used calculus and they worked on infinite series. So Madhava's work predates both Newton and Leibniz by 250 years and predates Gregory's work by at least 200 years. This is Dr. George Georgis Joseph. He's a professor of mathematics in the University of Manchester. I think he's still a professor in the University of Manchester, who wrote that the Kerala school identified the infinite series, that is Madhavacharya, one of the basic components of calculus, in about 1350. The discovery is currently and wrongly attributed in books to Sir Isaac Newton and Gottfried Leibniz at the end of the 17th centuries. Professor Joseph has written a book by name The Crest of Peacock, The Non-European Roots of Mathematics, published in 2007, and in which he writes, the brilliance of Newton's work at the end of the 17th century stands undiminished, especially when it came to the algorithms of calculus. However, but other names from the Kerala school, notably Madhava and Nilakantha, should stand shoulder to shoulder with him as they discovered the other great component of calculus, the infinite series. There is a YouTube video on this by Professor George Georgis Joseph. Now, Shulba Sutra. This is the geometrical formula. This belongs to the Vedic period, and the Vedic period is certainly prior to the year 2000 BC. Why do I say it must be prior to 2000 BC? Because the Vedas and the Saraswati River are very intimately connected. In fact, the Vedas were composed in an area of Punjab, Rajasthan, this area where Saraswati River was flowing. And there are references in the Vedas to Saraswati River, very glorious references, which far outnumber the references to Ganga. Ganga is also the sacred river, like Saraswati was. But whereas there are suktas, that hymns, referring to Ganga were 2, referring to Saraswati were 50. So Saraswati was a very predominant component in the Vedic time, in their life. And if you today see, look at this. This is the North India map. This is the Saraswati River. What you see here is Saraswati River. On the left-hand side is the Sindhu. Saraswati was flowing almost parallel to the Sindhu River. It starts at the Shivalik mountains in the Himalayas, which is Uttarakhand and north of Uttarakhand. From there it was flowing, and it was more dominant than the Sindhu River at one time. Today, we can get the picture of this by remote sensing satellite. That is, the picture is taken from the sky of the river bed, which is submerged or which has gone below the earth. River had dried up around 2000 BC. It took about 300 years, about 3 centuries to dry up. And when it dried up, people started moving away from that region. If you look at those pictures, you will find all these dots. You see there are many dots. tens or hundreds of these dots. The dots indicate settlements. You see that around the Saraswati River, somewhere in Rajasthan, you will find too many dots, which means human settlements, which can be identified based on the satellite pictures. On either side of the river, there are such settlements, and you see these settlements have moved inwards to the river. That means when the river started drying up, see, the river was very wide at times. At places, it was 5 kilometers wide. At places, it was 8 kilometers wide. And as the river dries up, then to fetch water, you have to go something like 2 kilometers. Then the settlement also starts shifting into the riverbed inside. So this can be traced, and scientists say that it took about 300 years, around 2000 BC, to dry up. The river entirely dried up. Then people migrated from here. A section of the people migrated to Bengal, a section migrated to Kashmir, and a section migrated southwards, and especially a section from Bengal migrated back to Goa. They are known as Saraswati Brahmins. But if you count the number of these settlements, there are more than 300 such settlements that can be traced to Saraswati River. Therefore, when you talk about a Vedic period, it is prior to the drying of Saraswati. That means prior to 2000 BC. And you also see that there are references to Saraswati River in the Ramayana. In the last session, we saw that Ramayana's period could have been around 5000 BC, and there are at least 2 references in Ramayana for the Saraswati River. One reference comes when Bharata from Kekaya, after the death of Dasharatha, Bharata was recalled from his grandfather's place, that is Kekaya, that is Afghanistan, Takshashila, Kekaya, that area. From there back to Ayodhya, he crosses Saraswati River. Valmiki gives a very detailed description of the 7 days journey of Bharata, where he crossed the river, which village, where he camped, all these kind of things he describes, and he refers to Shatadru River, Saraswati River, etc. Another reference comes when Sugriva sends his team in search of Sita. He refers to the Saraswati River. So that period tallies well with this finding that it is prior to 2000 BC. So I would say that these Shulba Sutras, which are found in the Vedas, must have been as ancient as the Vedas, that is prior to 2000 BC. Their geometrical formulas are discussed in these Shulba Sutras. And 7 acharyas, composers of Shulba Sutra, or compilers of Shulba Sutra, are known today. They are Boudhayana, Apastamba, Katyayana, Manava, Maitrayana, Varaha, and Vedula. These are known. What are unknown we can't discuss, so these are known. And we will look at what these people have contributed. Apastamba and Katyayana provide a formula for evaluating square root 2 correct to 5 decimal places. What does this mean? This means that they were clear that it's an irrational number. An irrational number is one which cannot be expressed as the ratio of 2 integers. Pi is one such number. Square root 2, square root 3 are such numbers. So square root 2 was evaluated to correct to 5 decimal places by Apastamba and Katyayana. The Pythagoras theorem was known to the Vedic scholars. This Pythagoras belonged to the period of 580 to 500 BCE. that is 6th century BC. But we are referring to Boudhayana Acharya, who is a well-known ritualist in the Vedas. Boudhayana Acharya, he must have been a few thousand years earlier to Pythagoras. What we call as the Pythagoras theorem, that is in the right angle triangle, with the base as x and the vertical side is y, and the hypotenuse is square root of x square plus y square. This is called the Pythagoras theorem today, but it is not very clear, not very certain that Pythagoras was the original formulator of this theorem. Reference to Pythagoras comes for the first time in the books of Euclid. Euclid was a Greek author. He has written a book called Elements. It has 5 volumes, in which he refers to this theorem. He does not refer to it as Pythagoras theorem, but calls it as theorem number 47. And says that some people refer it to Pythagoras. This is the first reference of this formula attached to Pythagoras. And notice that Euclid was referring some 200 years after Pythagoras. Look at what a modern scholar has to say. This is Alexander Volodarsky from the USSR Academy of Sciences. Says Professor Volodarsky, the question whether Pythagoras himself was the discoverer of it and its proof has by no means been solved. The tradition attributing the theorem to Pythagoras started about 500 years after the death of Pythagoras. Euclid had referred to it, but not emphatically. He said some people say that it belongs to Pythagoras or it originated with Pythagoras. So the actual tradition started around 500 years after Pythagoras. Although various attempts have been made to justify the tradition and trace the proof to Pythagoras, no record of proof has come down to us earlier than given by Euclid's Elements. But Boudhayana Acharya, Boudhayana Shulba Sutra, which occurs in the Krishna Yajurveda, Taittiriya Samhita, Boudhayana Shrauta Sutra, 30th Prashna, says this. The Sanskrit quotation is given here. And he also gives those triplets. These triplets are those the very same triplets which we by heart in the school. 3 square plus 4 square is equal to 5 square, 5 square plus 12 square is equal to 13 square, etc. So he has given several triplets. Some of them we have studied in the school, but some of them are not referred to us. See the last one, 12, 34 and 35, we did not know. At least I did not know. But it is very clearly stated by Boudhayana Acharya, that the diagonal of a rectangle, he is not referring to a right angle triangle. He says the diagonal of a rectangle, which divides a rectangle into 2 triangles, right angle triangles. So the diagonal of a rectangle produces the sum of areas which its length and breadth produce separately. That is the statement. I don't have to explain this because we are all familiar with this. Varahamihira. This Varahamihira was a great genius. He was not only a mathematician, but he was also a polymath. He was competent in several fields. His Brihat Samhita, Varahamihira's time is around 505 to 585. He's the next generation after Aryabhata. So Aryabhata died in 550. So this gentleman was there until 587. He wrote the Brihat Samhita, which is a huge encyclopedia. It had 106 chapters, covers various topics like astrology, planetary movements, that is astronomy, eclipses, rainfall, clouds, architecture, growth of crops, manufacture of perfume, matrimony, domestic relations, gems, pearls, and rituals. The volume expounds on gemstone evaluation criterion found in the Garuda Purana and elaborates on the sacred 9 pearls from the same text. He wrote a treatise known as Pancha Siddhantika, which is the summary or essence of 5 other treatises earlier to him, such as the Surya Siddhanta, the Romaka Siddhanta, the Paulisa Siddhanta, Vasishta Siddhanta, and Paitamaha Siddhanta. There is an interesting anecdote about Varahamihira, that he was a great astrologer, and he predicted the death of the crown prince. When the prince was born to the king called him and asked him to make a horoscope, and then Varahamihira cautioned him that there is a possibility of a death of the prince. Then he also said that he may meet his end from a wild boar, Varaha. And the king took every precaution that the child is not exposed to the animals at all. However, one day when the child was sleeping, there was an earthquake, and the bronze statue of a Varaha, which was kept at a height, fell down on the child, goring him to death, and the child died. This made the astrologer very famous because he had predicted thing, and that is how his name became Varahamihira. That is the legend. This Panchasiddhantika notes that the Ayanamsha, or the shifting of the equinox, is 50.32 seconds. See, when you say seconds, it's an extremely small measure, but he showed what the equinox shifts from year to year by a very, very short interval. He improved the accuracy of sine tables of Aryabhata, gave the trigonometric formula like this: sin x is equal to cos pi by 2 minus x, sin square x plus cos square x equal to 1, 1 minus cos 2x by 2 is equal to sin square, etc. Calculus, trigonometry. And he mentioned in his Brihad Samhita that the multicolored rays of the sun being dispersed by wind in a cloudy sky are seen in the form of a bow, which is the rainbow. Referring to an earlier treatise, that is one of our darshanas. There are 6 darshanas referring to the Vedic tradition. One of them is Nyaya Darshana, belonged to Gautama. Akashapada Gautama is his full name. And in which he says, that which cannot be perceived with the naked eye can be perceived with the lens made up of glass, mica, or crystal. Spatikantari topa upalabdhe. It can be perceived through the spatika. Spatika means crystal. This is called the Katapayadi Sankhya. It is a coding system where the alphabet is assigned with certain weightage. It's a number system using alphabets. Look at this shloka. This shloka has been quoted by Swami Bharati Krishna Tirtha, who wrote the book by name Vedic Mathematics. In the blurb of the book, if you have the book, you look at the blurb of that, the cover page of that, underneath that, this shloka has been quoted and explained. The shloka is Gopi Bhagya Madhuvrata Shringi Shodadhi Sandhiga Khala Jivita Khatava Galaha Lara Sandhara. Okay. What it means, ostensibly what it means is, O Krishna, the good fortune of the gopis, the destroyer of the demon Madhu, the protector of cattle, the one who ventured into the ocean, destroyer of evildoers, one with plow on the shoulder, and the bearer of nectar, may you protect us. Ostensibly, it is this. But if you use the Katapayadi coding protocol, with the respective numerical values ascribed to them, then you get this. The value happens to be pi equal to 3.14159265, something like 30 decimal places. This is what this shloka actually represents. I was told that this shloka has another level of interpretation, which I do not know right now. But some people told me that it has another level. Let us look at another domain, metallurgy. Ancient zinc mines were in existence in Rajasthan, Zawar at Rajasthan, as early as 400 BC. Mind you, 400 BC. Bharat can take legitimate pride for having developed a process of extracting zinc from its ore by distillation. This method of distillation is a very tricky method. See, zinc melts at a temperature of 997 degrees centigrade. But it evaporates, the liquid zinc will evaporate at 1000 degrees centigrade. So there is only a 3-degree window when zinc melts and it evaporates. If you want to extract the metal from the ore, you have to heat it to a temperature of 997 and collect the liquid before it reaches 1000 degrees centigrade. So there is only a 3-degree window. Therefore, it is a very tricky method. But India had developed this method around 400 BC, and it was unknown in Europe until the 18th century, until in 1748 AD, William Champion introduced this method in England from India and patented it. This is Mehrauli near Delhi, in the outskirts of Delhi. What you see is the Qutub Minar, and what you see on the left, there is the arch, and in between the arch there is the pillar. This is called the iron pillar of Mehrauli. This complex was a temple complex before, there is a plaque put up by the Archaeological Survey of India that some 27 temples were destroyed here and a mosque was built, and Qutub Minar exists beside it, and it is attributed to Qutubuddin Aibak, but at least the lower portion of the Qutub Minar was certainly not Aibak. Maybe the upper stories, maybe 3 floors or so, were added by him, if possible, because it is bald and it is without sense. It doesn't gel with the bottom structure. But we are not into Qutub Minar, we are looking at the iron pillar of this, because we are discussing metallurgy. So this iron pillar is about 24 feet tall and about 1 foot in diameter. And it has inscriptions, possibly Sanskrit inscriptions all around its body, which are faded but not entirely, not entirely vanished. So you can make sense out of it, provided you look at it very carefully. And it weighs about 6 tons in weight. 7.32 meters tall, 30 to 35 centimeter in diameter, and 6,000 kgs in weight. Exposed to open weather for more than 1500 years, but is a rustless wonder. It is iron pillar. It is not a stainless steel pillar. It is stainless, but it is not stainless steel pillar. It is iron pillar. And its composition of the pillar is this, see, iron 99.72%. So less than 1% rest of the metals. Copper 0.034%, carbon 0.08%, silicon 0.046%, sulfur 0.006%, phosphorus 0.114%, nitrogen 0.032%, and manganese 0.0%. If it is 0.0, why did you mention it? We mention it because manganese is important in the stainless steel. The stainless steel gains its property of stainlessness because of manganese. And this contains no manganese at all. Therefore, it is an iron pillar, but it has been exposed to the atmosphere for 1500 years or more than 1500 years. We don't know exactly when it was established. Estimation is that it is 1500 years. But it doesn't rust. A similar wonder can be seen in Karnataka near the Kotachadri temple, or not near, upon the Kotachadri temple near Mukambika temple, Kollur. Behind the temple, there is a Kotachadri hills. So if you climb the hill, you can see an iron pillar which is taller than this. But that too doesn't rust. We don't know how ancient it is. Ayurveda. Ayurveda divides the system of medicine into 8 categories. Shalya, Shalakya, Kaya Chikitsa, Bhuta Vidya, Kumara Bhritya, Agada, Rasayana, and Vajikarana. Shushruta Samhita, there are 2 major treatises in Ayurveda. One is called Charaka Samhita, which refers to the physiology and medicine. Shushruta Samhita largely refers to surgery. Sushruta Samhita delineates 8 varieties of operations. procedures. Chedana, Bhedana, Lekhana, Vedana, Esana, Aharana, Vishravana, Sivana. Incision, excision, scarification, puncturing, exploration, extraction, evacuation, and suturing. The Charaka Samhita lists over 341 plant substances, 177 drugs of animal origin, and 64 mineral compositions. They call it Bhasma, mineral compositions. The Shushruta Samhita lists 300 different operations, mind you, 300 different operations, 42 surgical procedures, 121 surgical instruments, 101 of them are blunt and 20 sharp instruments. Some pictures I have given here, borrowed from. There are 121 of these instruments. I'm referring to George Guthrie. Guthrie was a cardiovascular surgeon around 1800 AD, that is 200 years ago. He participated in the Battle of Waterloo on the British side. Cardiovascular means referring to the heart. Cardio means referring to the heart, but vascular means, see, referring to the arteries and the veins and all these things which are attached to the heart. See, he was a very important surgeon on the British side. I probably was the head of the medical team. Because in the war, what happens is, the weapons are used and weapons are used to kill. So the wounds that are inflicted and received are not light, they are deep cuts. So a surgeon's job is to actually treat these people and put them together and suture them and make them, treat them. And this treatment would require a great insight, in the sense that it is not just that you put together and sew the skin. If a vein is cut or an artery is cut, you will have to connect the vein and artery together and make sure that they are connected and the blood flows through those veins or through arteries. So such surgeons are known as vascular surgeons, and Guthrie was a great cardiovascular surgeon. He is highly respected. Even today, when people, in honor of Guthrie, they open Guthrie Cardiac Center, like we say Vivekananda College. So like that, they will honor him by giving his name to the centers. So that highly respected gentleman, a surgeon. So look at what Guthrie says about Indian surgery. It was surgery above all that the ancient Hindus excelled. Please remember what Professor Selenius said about mathematics. He said, this is the greatest contribution of India. What? Mathematics. Now, Guthrie says, surgery above all that the ancient Hindus excelled. He says, this is his domain, and Selenius was talking about his domain, but both of them give great tribute to India in making this kind of statements. Shushruta described more than 100 instruments. This was their greatest contribution to the art of healing, and the work was bold and distinctive. It is not unlikely, though difficult to prove, that some of it were of Greek origin. Notice this. He doesn't know, but he guesses, indulges in a guesswork. It is not unlikely though difficult to prove that some of it were of Greek origin. Some indeed state that the Greek drew much of their knowledge from the Hindus. This Buddha thing, this is around 1800, 1815 was the Battle of Waterloo. This is a time when the British started feeling that all science actually belonged to Europe. And this trend continued for a century, starting from around 1800. By around 1900, the European pundits were very certain that India did not have much science. But by 1750s, when they started their empire in India, they were very eager to learn whatever India could offer, and they were giving all kinds of tributes. I will show some of them in a later session. But in about 100 years after their empire was established, they developed their self-esteem to such an extent, they started feeling that the rest of the world, and India especially, did not have anything in the past. And our present attitude and understanding is derived from these British Pandits. Botany. The Western stream of botany, Western knowledge of botany, started or developed by Aristotle, the great scholar in ancient Greece. His time was 384 BC to 322 BC. Aristotle worked on several fields. One of them was botany. And today in our BSc degree, when we teach botany, the names used are of Greek origin. Aristotle's classification is being taught. However, in India, Rigveda classifies Vriksha, Oshadhi, and Viruddha. Atharva Veda subdivides the herb into 7 types based on their morphological characteristics. Shushruta Samhita is certainly before Christ. How many centuries we really do not know. If you look at the writings of European scholars, they will say it is 1st century BC. But they're really not sure. Nobody knows anything about BC. In India, there are so many things which they could not connect, they could not estimate. Whatever they could not estimate, they would say 1st century BC or 2nd century BC. But it is certainly more ancient than that. So Shushruta records the plants are of 4 kinds. He says Vanaspatayo Vriksha Viruddha Oshadhaya iti. Then he says, what do you mean by Vanaspati? Those plants that bear fruits without flowering is called Vanaspati. What is Vriksha? That bear both flowers and fruits is called Vriksha. Viruddha is a stemless and spread out. That is bushes are called Viruddha. Oshadhi is wither away after the fruits ripen. This is the classification of Sushruta Samhita. Mahabharata Shanti Parva, I have quoted several shlokas here. Mahabharata is written by Vyasa, as we understand, but the entire Mahabharata may not be, there is a very strong opinion about this, may not be all the 18 chapters, or not chapters, the Parvas, the books, all the 18 chapters may not have been written by Vedavyasa himself. It must have been written by others, maybe by his disciples. One of them was Jaimini, but I do not know to whom this Shanti Parva is referring to. It is a major Parva, very bulky and major Parva. a lot of discussions about variety of things. May not be written by Vyasa. Vyasa belongs to the period of 3000 BC. But this may have been added later also, we do not know. But certainly from our point of view, it is very ancient. So this Mahabharata Shanti Parva refers to a dialogue between sage Bharadwaja and sage Bhrigu, referring to the plant life as this. Both Bharadwaja and Bhrigu are Vedic rishis. I have given the Sanskrit verses, but I'll read the English part. Leaf, bark, fruit, and flower fade from heat. Since the plant fades and decays, it has a sense of touch. By the sound of wind, fire and lightning, fruits and flower decay rapidly. Sound is received by the ear, so the plants have a sense of hearing. See, saying that they have a sense of touch, they have a sense of hearing, they have a sense of taste. See, all the five senses which humans have, they say that the plants also have. May not be well developed, may not be as developed as in the humans or animals, but they do have. The creeper surrounds a tree. From all sides it moves. Path needs to be seen. Therefore, plants can see. By a variety of good and bad smells and aroma, the plants blossom disease-free. Therefore, plants can smell. Heat and light digest the water that is drawn by the plant. From the digested water, fluids come into being and growth occurs. Just as one draws water through a lotus petiole applied to the mouth, you put a straw to your mouth and dip it in the liquid, and you can suck that liquid up. It says that plants drink water like that. Just as one draws water through a lotus petiole applied to the mouth, so also plants drink water endowed with air, along with air, with their feet. Therefore, the plants are known as Padapaha. Padai Pibati Padapaha. Those who drink through their feet are known as Padapas. By the drinking of water through their feet, exhibition of diseases, by the response to diseases, sense of taste exists in plants. From their grasp of joy and sorrow, from the healing of wounds, I perceive the existence of life. Otherwise, how will a wound heals? Therefore, there must be life. So plants are sentient. This is the discussion between two sages as recorded in the Shanti Parva. The microscope was invented by Antony van Leeuwenhoek. Belongs to the period 1630 to 1723. He invented the microscope, but another scientist, you can say, Robert Hooke, he used the microscope to observe very minute things and record. The kind of things he observed are the structure of a plant cell. Cut the plant and see what is inside through a microscope, and he described by drawing pictures of what he has seen, and then he gave a description. That book is known as Micrographia. He has described, he has drawn, and then described the structure of a plant cell. Then you would take a drop of water, put it under the microscope, and see what all he would see. The bacteria moving or the amoeba moving and all that kind of things he described in his book. This is around 1650. 1635 to 1703 was Robert Hooke. So 1650, 1660, that was the period. Until then, people did not know what was a plant cell in Europe. But in India, there is a book by name Vriksha Ayurveda. It is attributed to sage Parashara. Which Parashara is this, we do not know. One Parashara was the father of Vedavyasa. That must have been 3000 BC. But we do not know whether it is the same Parashara. But what we know for sure is that Kautilya's Arthashastra refers to the Vriksha Ayurveda. Kautilya is said to be around 326 BC. This also is not certain. It could have been much earlier, because this 320 BC is based on the records, the Greek records of the scholars who had accompanied Alexander, who invaded around 326 AD. Sorry, 326 BC. He came to the border of India and then turned back and went back to Greece. They have recorded certain names, not correct, not exact. They will say Zandrme. You don't know, you can make anything out of it. Zandrme. Sandra Kottas, they will say. Sandra Kottas. Sandrakottas. Sandra Kottas. So people interpret that this Sandra Kottas must be the Chandragupta Maurya of Magadha. That's what people interpret. It may be right, it may not be right. But based on the reference to Alexander, people say that Kautilya's Arthashastra belongs to that period. But even if we accept that, the Vriksha Ayurveda is more ancient than that. And see what Vriksha Ayurveda says about the plant cell. It says that the plant cell has 2 layers of skin, Valkala. Valkala is skin. Not 1 layer, but 2 layers. But it also says that it contains a colored sap. See, it's a liquid cell. See, plant is a solid, but the cell is a solid object. But then when you cut it, it contains a colored sap. Not merely a sap, but a colored sap. Then it says that it cannot be seen by the naked eye. It is not visible to the naked eye, it says. Anaveshwa. Then how did you know? Did you have a microscope at that time? We don't know that. But Vriksha Ayurveda records this, which cannot be refuted. It indeed has 2 Valkalas. It indeed has a colored sap. Ranjaka Yukta Rasashraya, it says. Yeah. This is Taittariya Brahmana, referring to Agnihotra. Agnihotra is the fire yajna using Agnikarya, expected to be done every Sandhya, morning as well as evening, according to the Vedic ritual or Vedic tradition. What Taittariya Brahmana says is this: one who practices Agnihotra in the morning and evening becomes strong like thunderbolt. He says Vajram. It can be interpreted either as thunderbolt or as diamond. He destroys his enemies by himself unassisted. His enemies remain conquered. Look at the references. It is the ritualistic portion of Taittiriya Brahmana. This is the glory of Agnihotra. This is about the Bhopal gas tragedy, the Union Carbide Company. Its poisonous gases leaked in 1984. On Monday, December 3rd, 1984, in the city of Bhopal, central India, a poisonous vapor, methyl isocyanate, burst forth from the tall stacks of an MNC pesticide company, Union Carbide, killing 2,000 people instantly and injuring more than 3 lakh people. Soon after the leakage of gas, Sri S.L. Kushwaha, a teacher from Bhopal, started performing his routine Agnihotra, and in 20 minutes, the symptoms of gas poisoning were gone from his home. He survived to tell his story. This is taken from a book called Pride of India, published by the Gujarat state government in 2006. Glimpse into India's scientific heritage. Space and time. Very interesting. We have seen in the earlier session the contributions of Albert Einstein through the special theory of relativity. He presented his theory of relativity in 1905, which connected the space and time. He said space and time, they're connected. Time is the fourth dimension, space and time duality, and developed that further into a mass and energy duality. This mass energy duality has been an ancient Vedantic concept which says that this entire material world is a manifestation of Chaitanya. But Chaitanya is not the energy that we talk in terms of you burn fuel, you get energy. It is not that kind of energy. It is an intelligent energy, that is Chaitanya. The consciousness is Chaitanya, but it is also energy. And the world is the manifestation of Brahman. This is the Vedantic concept. But the space-time duality was also one of the strong thoughts of Indian system. The Sankhya philosophy of Kapila Muni and Madhyamika philosophy of Gautama Buddha both contain a sutra. I came across this when I was reading Swami Abhedananda's book. I have quoted it here, Religion, Revelation and God. Swami Abhedananda was a sannyasi who was sent to America by Swami Vivekananda. Swami Vivekananda visited the West, that is America, for the second time in 1997. And he was there for a short while. In 1993, he was there for nearly 3 years. But in 97, it was a short while. After coming back to India, he sent Abhedananda to America to start the Vedantic Society and spread the message of Sri Ramakrishna. And Abhedananda was a very brilliant young Swami who started addressing the intellectual cream of American society. He gave several lectures, and his complete works extend to something like 10-12 volumes, which you can look at the website of Belur Mutt. They are compiled there. This is a small book, published standalone book published under the name Religion, Revelation and God, which is a collection of his lectures. One of his lectures, delivered in 1902, on the philosophy, on the Madhyamika philosophy of Gautama Buddha. That was the title of the lecture, in which he compares the various darshanas, especially the Sankhya Darshana and the Buddha's Madhyamika philosophy, Madhyamika Darshana, and then extracts the commonalities and listed them. He made 5 points as the common to both these philosophies, and the third point was this sutra. He identified this sutra as being common to both Sankhya philosophy and Madhyamika philosophy. And the sutra says this very interestingly. It says, Akasha sthitena chetasa kalam kurvanti. Man creates time by their mind out of space. See the beauty of this. He's talking about time and space and says it's a conception, it's a perception of mind, and it is an important point, important sutra of both these philosophies. What does this mean? This means there are people who have been studying this sutra from time immemorial, as long back as the Sankhya philosophy or the Kapila Muni's time. The students are studying this, and it is considered as a very important concept. It is a different matter whether the person who is by hearting understands this. That is true of Einstein's theory also. Not many people understand, even though we are exposed to it. But this thought of connection between the time and space is quite ancient in India. I was very curious to know whether this lecture was delivered before Einstein presented his theory or after he presented his theory. It was delivered earlier. It was delivered in 1902. So, yeah. And now the last point is the connection between science and spirituality. In the West, science and religion are considered to be two separate entities, whereas in India, science and religion, or science and spirituality, I should say, spirituality are complementary. They are treated as complementary fields. This difference in the perception, in the attitude between science and spirituality is complementary, and it is not confrontationist. But the West, it is very clear when science dominated after the scientific revolution, religion was pushed aside. When religion dominated during the Middle Ages, science was not allowed to flourish. But in India, it was not so. Both of them existed side by side, respecting each other.
Sir, shall we take up this topic next week, sir?
Yeah.
It will be good to take a break here.
Yeah, we'll take it up some other time. Fine.
Next week we can continue. Thank you, sir. So now the session is open for question and answers. I see Nagi sir has already raised his hand. Anyone else who has any questions, can use the raise hand option of Zoom and please indicate. Nagi, please go ahead.
Yeah, good evening, sir. So I had a few simple questions regarding Bhaskara, right? Your foils talk of Bhaskara II. So
Yeah.
was there a Bhaskara I?
Yeah, there was a Bhaskara I earlier, but not as prominent as Bhaskara II.
Okay, so typically whenever anyone talks of Bhaskara, it is Bhaskara II.
Yes, yes. When we sent a satellite, India had a satellite program started somewhere in 1970, 76 or so. The second satellite that we sent, the first one was Aryabhata. The second was Bhaskara, but that was Bhaskara II.
Okay. Yeah. So my second question was regarding when you're talking about Varahamihira, right, and his work on trigonometry. I just wanted to understand, because Sine, cos are all English words. So in what form did he express those formulas in sutras?
They called it Jia, Cha, and some other word related to them. They use Sanskrit words.
Acha, acha, okay. And the last question was, you mentioned about Bharati Krishna Tirtha.
Yeah.
So is that the Sringeri Swamiji?
No. This Bharati Krishna Tirtha was, I think he belonged to Govardhan Pita also. That is in Orissa.
Okay, okay.
And he passed away in 1960. See, there is a Bharati Tirtha today in Sringeri, but this Swamiji wrote, I mean, he's a very brilliant, I think he was a mathematician, scientist, and he was a PhD also.
No, in Sringeri also, there was a Bharati Krishna Tirtha who was a contemporary of Saint Vidyaranya. Okay. So I was just wondering if it was the same person.
No. See, the timeline is 1884 to 1960.
Okay. Okay, sir. Thank you. That's all.
Yeah. He wrote this book, Vedic Mathematics. It is available in the market.
Okay.
Vedic Mathematics.
Thank you.
Yeah.
Okay. Thank you, sir. Next question from somebody called Satya's iPhone.
Namaskara. Satyabodha here.
Namaskara, Satyabodha. Please. Go ahead.
Namaste. Idu namma Kodachadriyalli there is one iron pillar in Kodachadri also you mentioned.
Yes.
So I being a metallurgist, of course not metallurgist, only having a degree in metallurgy. Is there anything more about it, or can we get something more on that? Anyway, this Delhi iron pillar we studied a lot, and it's really a puzzle. As you said, stainlessness without having manganese is a mystery. I mean, at least we are not able to understand. So, Kodachadri, you have anything more on that?
No, I don't know yet. But there is one Professor Anantaraman had worked on that. I see when he visited Kodachadri, he came to Suratkal and he delivered a lecture. I remember that.
Okay. Maybe next time we go to Kodachadri. We were there in Kodachadri last year also.
Yeah.
Somehow we missed it. Next time we will definitely make a point.
Yeah, it is considered to be the Shula. Devi.
Okay.
Yeah. So next question from GT Deshpande, sir.
Namaste, sir.
Sir, in your slide number 70.
No, I am not able to hear you.
No, it is unmuted.
Sir, you have to talk a bit louder or keep the phone closer, sir.
Yeah. Sir, am I audible now?
Barely. You have to be louder.
Okay. Sir, now?
Yeah. Please go ahead, sir. Let us see. Some of us will pick it up and translate.
Sorry to waste.
Sure. Please go ahead with your question, sir.
Yeah. Sir, in your slide number 78, you could show from the remote sensing agency, whatever they have shown, the river Saraswati, which is extinct now. It is flowing from Shivalika hills towards west as well as towards east. It is branched into two parts, one flowing towards west and another branch flowing towards east. So, of course, why I'm saying that is, when we visited Prayagraj, there Ganga, Yamuna, Saraswati, they merge together, and Saraswati is extinct, they say.
Yeah.
And when we visited Badrikashram, there also they say this Saraswati existed earlier and is extinct now. Yeah. And even in Gujarat, western part, near Narmada part, there they say Saraswati was existing and extinct. So that was confusing earlier, but as per your slide, from Shivalika, it is flowing towards west as well as towards east. That gives a confidence for our, whatever people talk.
Yeah. See, what flows to the east is called Yamuna.
Uh-huh.
When Saraswati dried up, Yamuna became stronger.
Uh-huh.
And also that, see, the water from the Himalayas keep flowing, right?
Yes.
It went in the direction of Sindhu. It strengthened Sindhu. Sindhu became more prominent when Saraswati dried up. So is Yamuna. Yamuna became stronger when Saraswati dried up. So Saraswati, I do not know exactly where it originated and where it, flowed, but they say it started in Shivalik mountains, and it was very, very prominent river.
Achha. So that means
they photograph the alluvial soil, that is Ave Mannu, which deposits on the riverbed, which can be identified by its radiation quality. Therefore, the photosensitive cameras, that is thermoluminescence cameras, they are able to identify the riverbed. The present riverbed, or presently the riverbed has sunk so deep in Rajasthan, it may be something like 100 to 140 feet below the surface. But yet they are able to trace it. This is the satellite pictures.
That means we can we understand that Yamuna and Saraswati both existed together, or Saraswati became Yamuna?
It could have existed together. But when the water flow in one direction, because of it could be because of the earth plate moving and earthquakes happening, so that the levels, the surface levels change. So the river direction also changes, right? So in that sense, the water started flowing into Yamuna on one side and Sindhu on the other side.
Yeah. Okay, sir. Thank you.
Yeah.
Okay, sir. Any other question? Okay. So if there is no other question, we will end the session today with a Shanti mantra.
Yeah.
Sarve bhavantu sukhinah.
Sarve
Bhadrani Pashyantu
Kashchit dukkha